Have you ever imagined living on another planet? The allure of Mars has captivated the minds of humans for generations. Known affectionately as the Red Planet, Mars stands as the next frontier for potential human colonization. As Earth becomes increasingly crowded, the dream of expanding our horizons beyond our home planet grows more vivid each day. This video series aims to explore the fascinating possibility of transforming Mars into a habitable environment. Can we really turn the barren landscapes and thin atmosphere of Mars into a new Earth? What would it take to make the Red Planet a place where humans could live, work, and thrive? The concept of terraforming, modifying a planet's environment to resemble Earth's, is not just science fiction. It's a scientific challenge that could define the future of humanity. As we stand on the brink of becoming an intergalactic species, the question isn't just can we, but how will we? Let's delve into how we might turn this dream into a reality. But first, what exactly is terraforming? Picture yourself as a cosmic gardener, but instead of tending to a backyard, your garden spans an entire planet. That's terraforming. It's an ambitious process where we modify a planet's environment to make it habitable for Earth-like life. Let's delve a bit deeper. Imagine Mars, a barren landscape with chilling temperatures and thin air mostly composed of carbon dioxide. Not exactly a weekend getaway spot, right? But through terraforming, we could transform this inhospitable place into a world where humans could potentially walk around, just like on Earth. The first step in this cosmic gardening involves tweaking the atmosphere. Mars needs a thicker atmosphere to support life and protect against cosmic and solar radiation. By introducing greenhouse gases, scientists propose to warm the planet, a process akin to turning up the thermostat in your home during winter. Next, we address the frigid temperatures. Mars often dips below -80°C at night. By warming the planet, we not only make it more comfortable, but also potentially unlock water resources. Water is trapped as ice in the Martian poles and soil. Heating the planet could turn this ice into liquid water, essential for life as we know it. But where does this water go? Here comes another gardening tool, seeding life. Introducing microbial life forms could kickstart biological processes to further modify the atmosphere. These microorganisms could produce oxygen through photosynthesis, just as plants do on Earth, and there's more to it. Modifying a planet to support human life also means establishing a stable, breathable atmosphere, creating a viable water cycle, and ensuring the soil can support agriculture. Each step is interlinked, building towards making Mars not just livable, but a thriving new home for future generations. With these changes, Mars could, theoretically, support human life. How could we possibly start terraforming Mars? The journey to transform the Red Planet into a habitable world is not just a flight of fancy, but a complex challenge requiring a toolkit filled with advanced technologies and innovative methods. Firstly, consider the creation of an artificial magnetosphere. Mars lacks a significant magnetic field, which on Earth serves to shield us from harmful solar winds. These winds strip away atmosphere and would be lethal to any aspiring Martian atmosphere. To counteract this, scientists have proposed deploying satellites to generate a magnetic field, or inducing the planet's core to revive its own magnetic field. This artificial magnetosphere would protect the planet, allowing us to proceed with further terraforming efforts. Next in our toolkit is the strategic use of greenhouse gases. Mars is incredibly cold, far colder than any winter on Earth. By introducing greenhouse gases into the Martian atmosphere, we could initiate a warming process. This could be achieved by deploying factories that produce these gases, or by directing comets, rich in volatile compounds, to crash into Mars. The heat trapped by these gases would gradually increase the planet's temperature, making it more amenable to life as we know it. Lastly, let's talk about thickening the Martian atmosphere. Currently, Mars's atmosphere is too thin to support human life, comprising mostly carbon dioxide with a fraction of the pressure of Earth's atmosphere. One fascinating proposal is to import ammonia-loaded ice from the outer solar system. Ammonia, a greenhouse gas, could be released into the atmosphere by heating these ices, significantly increasing the atmospheric pressure and contributing to warming the planet. These tools, from magnetic fields to atmospheric manipulation, are not just speculative. They are grounded in real scientific principles and research. With the right innovation and persistence, these could feasibly be the methods by which we bring Mars to life. These tools represent our first steps towards making Mars a second Earth. Scene script. How long would all of this take? Embarking on the monumental journey of transforming Mars into a second Earth is not for the faint-hearted or the impatient. It's a venture that spans generations, a true marathon in the cosmos. Let's explore the timeline for such an audacious endeavor. The initial phase, which involves altering the Martian climate to a state where it can start to support human life, is perhaps the most demanding. This phase alone, according to leading scientists, could take anywhere from 80 to 100 years. The process would involve a combination of industrial-scale production of greenhouse gases to warm the planet and the deployment of mirrors in orbit to reflect sunlight onto the Martian surface. Following this, the creation of a breathable atmosphere presents its own set of challenges and timeframes. This phase hinges on the successful growth of microbial life and later plant life, which would convert carbon dioxide into oxygen through photosynthesis. It is estimated that achieving a minimally breathable atmosphere could take several centuries. During this time, Mars would begin to see the formation of microenvironments capable of supporting simple plants and eventually more complex ecosystems. Moving towards a fully habitable environment where humans could live without life support systems would likely extend even further. This stage involves not only perfecting the atmosphere, but also stabilizing temperatures and developing sustainable water sources. This could push our timeline to 1,000 years or more. It involves an intricate dance of technology, ecology, and planetary engineering on a scale we've never before attempted. Throughout these phases, the advancements in technology and our understanding of Martian geology and climate would need to keep pace. The endeavor would also require unwavering commitment from multiple generations of Earthlings dedicated to the cause of expanding the human frontier. Patience would be essential, as we're playing a long game with Mars. Imagine humans as a species not just of Earth, but of the galaxy. As we contemplate the vast expanse of the cosmos, the notion of humans becoming intergalactic beings stirs both awe and an array of profound questions. What might it mean for our culture, our technology, and even our biological makeup as we adapt to new worlds? As we set our sights on other planets like Mars, we're on the cusp of becoming a multi-planet species. This monumental shift will likely see human culture evolving in ways we can barely begin to predict. Each planet we inhabit will not only broaden our physical horizons, but will also vastly enrich our cultural diversity. Imagine a future where the cultural tapestry of Earth is interwoven with new traditions born from the unique environments of other worlds. Technologically, the leap to becoming intergalactic beings will be underpinned by advancements that today seem the stuff of science fiction. Space travel could one day be as routine as air travel, with technologies possibly harnessing the energy of stars or bending the fabric of space-time itself for faster-than-light travel. Our tools and machines will need to be as adaptable as we are, capable of operating under different gravitational forces and atmospheric conditions. Biologically, the human species might begin to diverge based on the varied environments of other planets. Just as life on Earth adapted to land and sea, humans might evolve distinct traits suited to other worlds. This could range from enhanced radiation resistance to the ability to breathe different atmospheres or see in lower light conditions. As stewards of not just a planet but potentially an entire galaxy, our responsibilities will grow immensely. We'll need to develop ethical frameworks for interacting with any forms of life we might encounter, ensuring we respect and preserve the cosmic ecosystem. In embracing our destiny as an intergalactic species, we are not just expanding our geographic reach, we are evolving in every conceivable way. The cosmos could one day be sprinkled with the descendants of Earth. As we stand on the brink of interplanetary colonization, the future is as vast as space itself. Picture this: a world where the red deserts of Mars blossom with the green of Earth-like life, where humans stepping beyond their cradle become citizens of not just a planet but the cosmos. This isn't just a dream, it's a voyage we are embarking on together. The journey of terraforming Mars poses a canvas for humanity's greatest aspirations. It challenges us to innovate, to persevere, and to expand the boundaries of what it means to be human. Each step in this transformative process not only reshapes a distant planet, but also redefines our place in the universe. So reflect on this monumental undertaking. What role might you play in this grand narrative? How does the thought of altering a planet's destiny stir you? If you're intrigued by the prospect of intergalactic humanity, make sure to like, subscribe, and join us at the SPACEDUDE channel for more cosmic insights.